Hello, I am Vyacheslav Yushkov. I am a secondary magister student of the Laboratory of Nanophotonics and Metamaterials of Lomonosov Moscow State University. I will be a tutor in this project.
Hello, I'm Simona Etinsky. I'm a second-year PhD student of quantum computation at the University of Paris, and I will be your co-tutor in this project. So let's start with what is this project about. So it is dedicated to so-called optical computers that are actually the elements that will be built into the optical computers. And the first question that you will probably be asking is, what are they and why do we need them, actually? And as you probably know, we had some long history of development of the current computers that you use today, like your personal computer or your mobile phone. And as you also probably know, so early in the history, we didn't have the same technology. So it was first based on some light bulbs, then we made a huge jump when we started using transistors and creating integrated circuits and microprocessors based on them. But what it seems today, so from what we see in the experiments, is that we reached our physical limits and that we cannot produce anymore with the same technology something that has better computational and higher computational power. So what we need to do in that case is that we should start thinking about some different technologies. And one way would be to start using light signals instead of the electrical ones, with the goal to create so-called optical computer that will be made of the components that are similar to the current microprocessors, but which will be operated by some different kind of technologies that is based on the light signals.
For these, various devices are being developed, one example of which is metasurfaces. There are two-dimensional quasi-periodic structures consisting of nanoparticles, disks, spheres or cubes less than 1/1000th of a millimeter in size. By changing the size of the particles and the distance between them, you can adjust the reflection from the surface. As a result, it is possible to obtain devices that can replace holograms and lenses we are used to. Of course, they can be more complicated. They can process images, for example, search for a given pattern, increase contrast, or highlight borders to simplify image processing. The development of a metasurface implements the search for image boundaries that this study will be devoted to. As part of the study, a metasurface model will be developed which throws out a volume from the image leaving boundaries. The optical scheme shown in the figure on the right will be modeled and processing the selected photo will be demonstrated. In our system, the laser beam will pass through the plate that forms the processing image and incident on the optical lens. The beam will be focused on the metasurface, from where it will be reflected, pass through the lens a second time and be detected on the camera. Ideally, it should look the same as in the bottom picture. The top line is the input, the bottom one is the output.
Okay, so let's start with what we expect that you know already. So the first requirement would be that you have some experience in programming. More you have, the better, and it would be extremely useful if you would already have been working with Python and its different libraries like NumPy and CPy, because we will use it quite a lot. But any kind of programming experience would actually help quite a lot, so you don't need to be that much experienced only in Python. The second thing would be that will be required is some kind of background in electrodynamics. So you should know what the current is, what is the charge, what is the difference between semiconductors and the electrics. So this kind of basic stuff, but even in case you don't, you will need to be ready to learn more about it, because this kind of understanding is really essential for a project. And through the project, we'll be explaining what is the light wave, how it interacts with the environment, how we can modify it. And finally, we'll aim to simulate it through numeric FTDT program. So at the end, you will be able to explain how this can all be used in order to produce an optical component. So hopefully you will join us and we'll have the opportunity to learn all of that. And if you don't, you probably don't have all the required knowledge, but if you are willing to learn and if you are eager enough to learn it, so we strongly encourage you to apply, and hopefully we will see you in the project.